Alright guys, obviously again, I'm in state tennis in Great Falls, and I know how much you love these videos, but we gotta keep moving. We're down to crunch time now for the year. There's just a few things left we have to cover, but we don't have time to wait. So, we've been talking about quadratic equations and functions for a couple chapters now. We've been talking about solving quadratic equations specifically for the last week or two. And there's 4 different levels, I guess, if you want to call them levels, or ways to solve quadratic equations. And they increase in difficulty, but they have to increase in difficulty as the equations or functions get more complex. So for the most basic quadratic functions, the easiest way to solve those is by taking a square root. And that's what we did yesterday. Just get the square root by itself and undo it, basically. Okay, so we can do that. The next easiest way is by factoring. I've been doing that for a couple of weeks. Right? Factor out its different pieces, set them both equal to 0 and solve. I'm not saying that's an easy process all the time, but it is easy compared to the complexity of other quadratic functions. So that one we can do as well. So now let's say something if we can't factor. What can we do? And the next thing we can do is called completing the square, and that is making it factorable. So completing the square, not finishing a visual square, but making it so that the quadratic function is a square, meaning that you squared something to get to it. Okay, so that's where we're going to go today. So first, let's do this warm-up from yesterday, solving using square roots. So go ahead and pause the video here. Take a couple minutes. I had a timer there set for 2 minutes. So take a minute or two and see if you can get all the way through this. It's just like the homework last night. This should be pretty simple. Go ahead. Okay, hopefully we all got it done, or at least made a valid attempt at it. I'm going to go through it now, just in case anybody got stuck. We want to divide both sides by 4. The idea is we want to get whatever is squared by itself first. So I'm going to divide by 4. Comes 1. I just have x plus 1 squared equals 9. So to get rid of the square now, I need to take the square root of both sides. Take the square root of both sides. Square and square root undo each other, and I just have x plus 1. Over here, the square root of 9 is plus or minus 3. So x could equal plus or minus 3 minus 1. I subtract 1 from both sides. So x could be 3 minus 1, or 2. Or it could be negative 3 minus 1, or negative 4. Okay, hopefully that's pretty simple. Moving on. Before we start completing the square, we need to go back to multiplication for a second. Now, what most people want to do when they see this is say, oh, easy, x squared plus 4. Square the x, or sorry, not 4, 9. Square the x and square the 3. Okay, that is not correct at all. Big mistake. Easy mistake to make, big mistake. This means we're multiplying something by itself. Right? That's what it means when I square something. So we got to distribute x times x, x squared. X times 3, 3x. 3 times x, 3x. 3 times 3, 9. Add those together, we get x squared plus 6x plus 9. Up here I said, notice the pattern. As we do these far, I want you guys to look for a pattern in the solutions. In these, which is a pattern we just need to follow. So let's do this one. We're multiplying x minus 4 by itself. So x times x times negative 4 is negative 4x. If I did this one also, that's another negative 4x, so it's going to be negative 8x. I just kind of skipped this step, put it all together. And then negative 4 times negative 4 is a positive 16. Okay, so there's a finished product. And this is the pattern yet. The third one, x plus 7 multiplied by itself. X times x. X times 7 is 7x. And if I do this one, that's another 7x. But now I can add them just like I did way back here. So that's going to be 14x. And then 7 times 7 is 49. The way I'm kind of doing these is trying to highlight the pattern without saying it out loud. So the last one, and then I'll show you. X minus 5 squared. X minus 5 times x minus 5. X times x is x squared. X times negative 5 would be negative 5x. Negative 5 times x would be a negative 5x again. The two of those together make negative 10x. And the last term, negative 5 multiplied by negative 5 is a positive 25. There's our four finished products. You can see the pattern. Change our pen color here and I'll point it out to you. The middle term is always double that one multiplied by this one. So if you multiply them together, you get 3x. Then I double it to get 6x. If you look at all three of them, that's the case. I have negative 4x doubled, 7x doubled, negative 5x doubled. Okay? So multiply the two terms and then double it. The first term, let me go backwards. The first term is always going to be this guy squared. So for all four of these, it was just an x. The last term is always going to be the last term squared. So the first term and last term are always going to be positive. Whenever I square something, I get a positive number. Okay. So let's look over here. If I start one, can we finish the end of it to make it a perfect square? And if we go back for a second, these are all perfect squares. I took one thing and squared it. That is the definition of a perfect square. Okay? So, what would have to go right here to make it a perfect square? Well, let's jump back a step. Let's move an x and x. That's how I get x squared. They're both pluses down here. So they both will be pluses up here. We multiply the first term and the last term, right, to get something, and then we double it to get there. So I need to cut that in half, which would make it a 4. Since it's a perfect square, these two things are going to be the same. And then that last term would be that last term squared. So the shortcut for doing this is divide this by 2, which is 1, and then square it. We're going to cut that middle term in half and then square it. And that's all there is to it. Because then, what's left over is factorable, like we just did here. We can factor this. X and x, this is positive, so I do 2 of these. Factors of 16 that add up to 8. That would be 4 and 4. If I really wanted to, that could be rewritten like this. And we can do the whole thing the other direction. Same thing over here. Once I have this, we can factor x and x. This is positive, so I do 2 of these. Plus, plus. Factors of 1 that add up to 2. Well, guess what? Those factors of 1 are 1 and 1. It's factored. Now I can say that that could be x plus 1 squared. And if I had that as part of an equation, let's say that there was a 9 over here, let's say that maybe this was 16. I could take the square roots of both sides now to solve that equation. Okay, so let's go back. This one on your own for a second. I just want you to fill in the blank to make it a perfect square. I'm going to help you with the first one real quick, just to remember the pattern, then I'll give you a minute to pause the video and get the other 3. Cut the middle term in half, which gives me 3x, and then square that. So, well, not, yeah, just the coefficient though. We're only squaring the coefficient. So 3 squared would be 9. Because x squared plus 6x plus 9 is a perfect square and is then factorable. Go ahead and pause it for a minute and a half and try to get the other 3. Cut them in half and square the coefficient. Go. Okay. Cut this in half. You get to negative 5 square it, positive 25. Remember, those have to be positive because anytime I square something, even if it was negative, a negative times a negative is now positive. Cut it in half, gives me 7, which is negative 7. But when I square it, it won't matter, positive 49. Cut this one in half, I get negative 10. Square it, and I get 100. Let's take a second and see what these would be once I factored them. Not part of what I asked you to do, but we'll just take a look anyway. X and X. If this is positive, so I do 2 of those. Factors of 9 that add up to 6. Well, factors of 9 are 1 and 9, or 3 and 3. Those are going to add up to 6, and we're done. Okay. That could be X plus 3 squared. And let's jump down into this one. We won't do all 4. X. This one's positive, so I do 2 of those. Guess what? These are always going to be the same no matter what they are. X. Factors of 49 that add up to 14. Factors of 49 that add up to 14 are going to have to be 7 and 7 because they have to be the same. So really, it's just going to be the square root of 49 goes there. And then that'll be x minus 7 squared. That pattern of factoring is always going to happen if we complete the square. And that's the reason we do it, because it makes the factoring super easy. So let's look at the whole thing. If I gave you something like this and asked you to solve it for x, first, we have to complete the square on the left. So I like to put a blank there to remind myself what I'm doing. Okay. So I'm going to cut this in half, which makes it 3. Square it. So this is going to be a positive 9. But the problem is, whatever I add to one side of an equation, I have to add to the other, or it's not balanced anymore. So I added 9 on the left. I need to add 9 on the right. Does that make sense? Whatever you add to one side, you have to add to both. I can't change the equation. I can change the way it looks, but I can't change the equation itself. Now we're going to factor this. X. This is positive, so 2 of these. Factors of 9 that add up to 6. Well, guess what? They have to be the square root of 9, or this isn't going to work. 3 and 3. So we're going to rewrite that over here. I guess we have 7 plus 9 is 16. We're going to rewrite this as x plus 3 squared. If I completed the square correctly, I can always do this step, and that's the whole reason we wanted to do this. Because now, I can take the square root of both sides to get rid of my squared. I have x plus 3 equals plus or minus 4. Here's the square root of 16. Subtract 3. X equals plus or minus 4 minus 3. X can be positive 4 minus 3, or x can be negative 4 minus 3. So there are quite a few steps, but none of them are really difficult steps. From here down is just what we did yesterday. Solved by taking square roots. So really, the only new thing is this step right here, where we complete the square. Then we factor a little bit, so it looks like what we did yesterday, and we finish it out. Okay? You need to go to pause it to finish getting this down. We'll do another one in a second. Okay, here's another one. And just for a second, let's say we try to factor this. So let's get it all together. This is just to show you why we sometimes need to do this. We have x. This is negative, so 2, or 1 of each, sorry. It's negative, so 1 of each. Factors of 5 are 1 and 5, and that's it. And I need to get an 8 somehow. There's no way to do it. I can put the 5 here and the 1 there, but I only get 4. If I put the 1 there and the 5 here, I get negative 4. I can't get 8. So this is not factorable the way it is, which is why we need to do complete the square. I can't take square roots either, because even if I get this by itself, and then I take the square root, oh, what's the square root of that? I don't know. So we can't do that either. And that's why we're in this boat. And so the easiest way around that is to complete the square. X squared minus 8x. We have to add something. Equals 5. Now I'm going to go ahead and do this right now. Because I need to remind myself that whatever I put right here has to go right here also. Whatever you add to one side, you have to add to both. And it's going to be positive no matter what. Because it's going to be squared. So, cut this in half. It's going to become negative 4. We're going to square it, so it's going to be positive 16. Okay. So over here, we can factor this. X and X. This is positive, so 2 of these. Factors of 16 that add up to 8. Another way to think of that is just the square root of 16. That's all we need to think about. They're both going to be the same. So I'm going to have x minus 4 squared. Okay. Now let's jump back over here. This was still over here. 5 plus 16 is 21. So I'm going to take the square root of both sides. Square root and square cancel. I have x minus 4 equals the square root of 21. So that's just a straight calculator problem. .58. And we solve for both of them. We're going to add 4 to both sides. Positive or negative 4.58. Plus minus 4.58 plus 4. So, x could be 4.58 plus 4, which would be 8.58. Or negative 4.58 plus 4 would be negative 0.58. So it's not always going to be pretty numbers, but that's why it wasn't factorable to begin with. If we jump back to the last one, the reason those numbers worked out is because it could have been factored. This one cannot be factored, which is why we get less pretty numbers or decimals. Okay? Go ahead and pause it if you need to, otherwise we're going to try on our own. Same thing is set up for you. I'll get it started. We're going to add something to both sides. And so we're going to get that. Go ahead and start from here. Go ahead and take 3 minutes and see if you can finish this all the way through. Ready, go. Okay. Hopefully we all got it done. We'll cut this in half, which gives me 2. I'm going to square that. I'm going to add 4 to both sides. So on the left, we can have x. This is positive, so 2 of those. 5 plus 4 over here is 9, by the way. Factors of 4 that add up to 4, well, it's just the square root of 4. So 2. We're always looking for the square root of this one. So we go right here. Just take the square root. So this could be x plus 2 squared equals 9. The square root of both sides. X plus 2 equals plus or minus 9. Subtract 2. X could be plus or minus 9 minus 2. So, positive 9 minus 2 is 7, or negative 9 minus 2 is negative 11, are my 2 possible solutions. Okay, so this one could have been factored. If these 2 numbers turn out nicely, it could have been factored. But that's alright, we're just learning the process. It's easy to learn the process on easy numbers rather than ugly decimals. Okay? Just a few for tonight. Day 9 from the homework sheet. The book assignment. Do the best you can. This video is posted on my website under the guest teacher tab on the right at the top of the page, and then under Algebra 1 if you want to watch any of this again tonight to help yourself figure out what's going on. You can also go to Khan Academy and search for completing the square. Really anything online, if you search for completing the square, you find this method if you want to see it again. Whether if you want to see somebody else or want to see mine again. We'll just do a little bit more practice of this tomorrow. I'll be back on Monday to answer any questions, and we're going to do one more method for solving quadratics, and then we're done for the year. Okay, so have a good weekend, guys, and I will see you on Monday.